Not mute, not unmute. To unmute me. Guys, I hope you can hear me now. Hi, so good morning. So we are starting a new lesson today, right? The heat. And the PDF is coming on the way. Until then, we'll have some sort of a different discussion. Yeah. So how was there was one seminar. Did you know that? You didn't know that, right? Did you know that there was a seminar? No, sir. Good thing. It doesn't matter, you have covered anyway the questions before, I think. No? You have gone through many of the force questions. You're okay with force, right? Then okay. And for the other people, Shiny and Shashindra, ask the institute to send you the recording of the fourth seminar that we discussed the orderly tute, right? That was online, so I'll send you the recordings. Huh? If I couldn't send, you ask the institute to send the recordings, they will send, right? And hope everyone has the everybody have the this orderly tute of force, and you should have covered it. Are you fine with the? Are you fine with the force parts?
So far fine, but still I need to
Yeah, go may have much of a deeper understanding. Yes, for that you will have to go through the questions and the theories back again with the understanding. So that will take time. That things take time, but you'll have to work on it somehow. So while you are working, you will be improving it. අර ගොඩක් තියෙනවා accumulate වෙලා නැති ඒකයි ඔය එකපාරට ගොඩ දාගන්න බැරි. But anyway, we'll have an exam in near future. After the exam, so you can have a bit of understanding how your level is. Even I can get a bit of understanding how your level is. So improve it, you'll be fine anyways. Right. So waiting for the PDF, guys. This is the morning session. We discussed the. These will be coming.
for the exam.
No, not for the exam. This will be coming in the the future lessons will be on these parts. Like this is electricity. So the Kirchhoff's law 1, 2 sort of things are there, and you will be studying these in E-Tech as well. So for the E-Tech people, it will be little fine, somewhat okay. And the calculations are there. Shall I show you the calculations there? Would you be scared? No, right? No, don't be scared. So this is the morning calculations. Voila. This is only one question and a part of it actually. So you're supposed to find the voltage differences of each and every resistor as well. So didn't do that. Now this is Kirchhoff's law. These sort of equations like simplifyings are there, aren't they? This is one complete question. Complete one question. Right? So no not that simple. So the questions will be somewhat bit complicated. Now these sort of a question was there in the past paper as well. So the first people who answered it, I don't know how did they manage the question. You have to have a really good understanding. That is why I'm trying to give it in the highest or the top level of a theory and calculation and everything. As far as I know, other teachers are going really shallow. Even the questions are really shallow, right? The questions are even really shallow, so they will somewhat safety video කියන එකට දා
මේකනේ
ඒ presentation එක ඒක කොපි කරන්න හරිය බෑ.
ඔය හදා ඕගොල්ලෝ නෑ.
හා.
එන්නේ
දැන් කොපි කරා?
මොකුත් වෙන්නේ නැහැ.
තේරෙනවද? තේරෙනවද? And training as well. Right, we are online back. So people, we are starting heat today. Ah. Nice. It's raining outside and right. Shall we start? Okay. So right. Someone raising their hands? No, right? Muhammad Akif. Is this 2025 Akif or 2027 Akif? Like two Akifs are there. I think it's 2027 Akif, I guess. Any questions? You can, I think the chat box are open, right? I'll ask when the other people come. Right, so come to the heat. Listen, now this part is important, right? So how do you explain heat? Now we are starting a new lesson. So fresh understanding, this is really important. I have to like try to focus as much as possible and try to understand the theory, and when it comes to the application, do the application with a proper understanding, not blindly, right? Right. So what is heat anyways? Now tell, what is heat? The people online, tell, what is heat? What do you understand by heat? What kind of a thing would you understand by heat? What is heat?
Energy.
Sort of energy, yes. It's one sort of energy, a kind of energy. How would you feel it? How would it, like how's the heat is like there in the objects? Temperature increase or decrease. So like is temperature and heat like two things or one thing? What do you say? Two things or one thing? Two things, yes. So because like temperature is one thing. The Yohasa is calling in the class time. Right. So the temperature is one thing and the temperature is one thing and the heat is another thing, right? But like temperature gives an idea about the heat, but the temperature isn't something that is heat, right? Those are two things, right? So the heat is basically something that remains as the kinetic energy of an object, right? Because when you are applying heat to an object, what happens there is like the kinetic energy of each and every molecule inside that object will be increasing. You know, when you apply the heat, the kinetic energy of each and every molecule or the atom inside that object will be increasing. So in that way, if I take it that way, what has happened like when I apply the heat? The kinetic energy has increased. So the absorption of the heat is like shown in a way of increase of kinetic energy, which means heat is a sort of a kinetic energy. Do you understand that? Heat is sort of a kinetic energy, because when you apply the heat, the movement of the molecules of the atoms will be increasing. That is why the water is boiling when the heat is applied. Its kinetic energy is increasing. So in that way, if I take it, so the kinetic energy remains in an object in a way of, the heat energy remains in an object in a way of kinetic energy. Do you understand that? That is really important. The heat remains there in an object in the form of kinetic energy. So the heat is somewhat the collective kinetic energy of each and every particle of the object, right? Because each and every particle of the object is moving, is shaking with sort of a vibration. That vibration gives a kinetic energy, right? That collective kinetic energy of vibrations of each and every particles gives the heat of a object. When you apply the heat, when the object is absorbing the heat, that shear, that vibration will increase, which means the kinetic energy will increase, right? So that means heat is there in an object in a form of collective kinetic energy of each and every atom. Do you understand that? Right. So the temperature is a measure of the heat, but like not directly the heat, but it's something relatively increasing when the heat is increasing, because when the heat is increasing of an object, right, heat energy is increasing, the temperature is also increasing, right. So looking at the temperature, we can tell either the heat increases or decreases, because when the temperature increases, heat has to be increasing. When it decreases, heat has to be decreased as well. But the heat doesn't only depend on the temperature. That is the first thing you have to remember, right? The heat doesn't only depend on the temperature, right? ඒ කියන්නේ temperature එකෙන්ම then now temperature is one thing, heat is another thing. We discussed that, right? No. Yeah, there is only one measure of measuring the heat level, right? There is only one measure. Like when the temperature is more, we tell it that the heat is more. Temperature is low, we tell the heat is low, right? That's all. Yes, it's only an indicator, right? Exactly, right? So if I explain it, I'll ask a question now. This is the question. This is very important, right? Now this is the question I'm asking. So you are given two of the things to tell this answer. Now I'm asking a question, right? This is something related to the heat, and if you understood the basic, you will answer this correctly, right? So this is the question, right? Now this is the question. You have two of the things. One is a iceberg, right? You say an iceberg is like a very huge one, like a mountain, maybe more than a mountain, and it is minus 30 degrees, 13 degrees of Celsius, right? I guess if you know it, you remain silent so the others can answer, right? So this is the mountain, and there's another coffee cup there, right? Two of the coffee cups, right? So one coffee cup is also here, and its temperature is 70 degrees of Celsius, right? Now the question is, which one has the highest heat, right? Out of the two of the objects, one is an iceberg of temperature minus 13 degrees, the other one is a coffee cup with a 70 degrees Celsius of a temperature, and the question is, which one has the highest heat in it of two of the objects? You don't tell it if you know it. You stay silent if you know it. If you studied it before, you stay silent so the others can like answer. They have to like, drain their, the thinking. Otherwise they will lose it. You tell. Which one has the highest heat? People online, tell it. Which one has the highest heat? Think and tell, come with the reason. Which one has the highest heat? Guys online, can tell which one has the highest heat? The iceberg or the coffee cup? You know? Just come up with a gut feeling at least. What do you feel like has the highest heat?
I can tell, but I don't know the reason.
You just tell it, doesn't matter. Now the यहाँ size come. What happened? Come. That's nice. Come, take the tute and come. Right, so we asked the question, right? So we were discussing about the heat, right? So we are like trying to understand the difference of the temperature and the heat, right? Now sit down, will you? Sit down. So now this is a question. You have given two of the things. One is iceberg, which is minus 13 degrees of Celsius. The other one is a coffee cup of 70 degrees of Celsius. Now this is a mountain. This is a coffee cup, right? But this is iceberg of like mountain size of a iceberg, and this is coffee cup. Which one? This one. This one. Why? Now that is the thing. So which has the highest energy, the heat? The iceberg or the coffee cup? Which would you select? Iceberg. What do you say? Which one has the highest heat? Iceberg or the coffee cup? At least tell your gut feeling. Now people online, Shiny, can you tell which one has the highest heat? Think. Which one? It's not obvious. I can't remember. Is it obvious? No. Which one would be it? Iceberg. Yeah, it's actually the iceberg. Iceberg, Shashindra, yes. Now the Shiny says coffee cup, yes. Yeah. Yes, now this is the thing. We discussed the temperature is only one thing to measure the level of heat, right? That is only one thing. So the heat, the complete heat of an object doesn't only depend on the temperature, right? Right, doesn't only depend on the temperature. Now if you know the answers, don't answer it before because that is spoiling. Others are thinking employee, it's not a good thing, right? So it should be what? It should be the iceberg. Why? Because if we take the molecule by molecule, the one molecule has a greater kinetic energy in a coffee cup because greater vibration is there. When the temperature is high, that means it has a greater vibration, which means a greater kinetic energy. But the number of coffee cup molecules, the coffee and all the molecules is very low, right? And when it comes to the iceberg, the kinetic energy of, the kinetic energy of one molecule will be very low. That is true because the temperature is very low. So the kinetic energy of one molecule or one atom will be very low, but the number of atoms will be or the molecules will be really high, like very high. Because of that, though the one molecule have like low kinetic energy or low heat, the collective heat of the mountain or the iceberg is more than that of the coffee cup. Can understand? So there's like two things. That first thing we discussed, the temperature is a sign of the level of the heat, right? That is one thing. So there's another thing now that we discuss here. The heat, one thing is heat depends on the temperature, but not only on the temperature, but it depends on the temperature. And the second thing here, what did we understood here? The heat depends on number of molecules. Number of molecules could be anything, molecules or atoms, doesn't matter, right? So number of molecules or atoms is a reading of what? A reading of mass. More the mass, more the number of atoms or the molecules, right? So it's a reading of mass. So we understood now two things are there. What are the two things? The heat depends on, one is temperature, the second thing is number of molecules, which is the mass, amount of matter is mass, right? It's mass. So mass and temperature are the two things. There's another thing that the heat depends. So we only, for now we know two things, right? You understood it? Yes. So now tell me the second question. If I, right? So if I take the coffee cup to close to the iceberg, right? If I take the coffee cup close to the iceberg, from where to where the heat will flow? Would it be from the iceberg to the coffee cup or would it be from the coffee cup to the iceberg? Yes, you know it already. Where to where? Coffee cup to the iceberg. Yes, because though the heat here is more, right? Though the heat here is less, always the heat flows from high temperature to low temperature, right? Remember that the heat always flows from high temperature to low temperature, right? Atomic, yes. Because when the two objects are getting closer, මෙන්න මේ atoms නේ close වෙන්නේ. ඒතර මෙයාගේ kinetic energy එක වැඩි, මෙයාගේ kinetic energy එක අඩුයි. So එතකොට atom එක close වෙනකොට මෙහෙම යන්නේ. ඒක you just remember it. Guys, we are writing it. I'm going to give a note. So you remember it, always the heat flows from high temperature to low temperature, right? So the heat flows from high temperature to low temperature. Now here, which has the highest heat? Now this is a mountain, no? Mountain or iceberg, right? This is just a coffee cup, right? And which has the highest heat? Which has the highest heat? The mountain has the highest heat, yes. And from where to where the heat flows? The heat flow is always from high temperature to low temperature, right? This is high temperature whatever the mountain. Take back the mountain. Okay. Bro, the mountain goes over, sir. This is temperature, and this is so this is low temperature, this is high temperature, right? This is high temperature. Right? And the flow of heat will be always from the high temperature to low temperature. Draw this one. මොකද? මේකද? 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 ඒ low kinetic energy, low vibration, පොඩි vibration එකක් තියෙන. මේක high vibration. Done? Nice. So did you understand up to now the theory that we discussed? So what did we discuss? The heat is a form of kinetic energy in the molecular level, right? Because the heat of an object is the collective kinetic energy of each and every vibration of the molecules, right? So that is what heat is in an object. So when the heat is applied, the temperature increases. Because of that, we can tell that the heat or the heat is depending on the temperature. The other thing we discuss here is the heat does not only depend on the temperature, but also the amount of the molecules, which is the mass, right? So two things are there, right? So shall we go through the tube now? Right, listen. The flow of energy from object of higher temperature to an object of lower temperature is called heat in physics. So the amount of heat flowing or the energy, amount of energy flowing from high temperature to low temperature is heat, right? That is true. No? So always for a heat flow there has to be two different temperatures, right? That is one of the definitions. That is not the actual definition, it's there in the middle. So basically we call the heat is flowing from high temperature to low temperature, right? The flow of heat from one object to another is called the heat transfer, right? The heat flowing from one to another we call as heat transfer, right? There are ways of heat transferring that you have maybe studied in the what are the heat transfer methods? Nice. Convection, conduction, radiation are the ways of how the energy is transferred or the heat is transferred, right? Right. So when heat is supplied to an object, that energy resides within the object as kinetic energy corresponding to the random motion of the molecules of the material of which the object is made is also called what? Heat, right? Can you highlight it? When heat is supplied to an object, that energy resides within the object as kinetic energy corresponding to the random motion of molecules of the materials of which the object is made. Highlight this part, up to this part. Heat is supplied to an object, that energy resides within the object as kinetic energy. So if someone asks you what is kinetic energy, you can tell them there is a format of kinetic energy that resides inside of a object as the vibrational kinetic energy of that object, right? Can understand that, right? They have to mentally think it. There's not something like ET wala wage mehema ekak hai kala gadget එකක් වගේ, that's not something like that. You have to take it to your imagination. That's all you have to do. So think it like imagine it. So the heat of an object remains as the kinetic energy of the vibration of each and every molecules of that object. That's it, right? Right. So we discussed the difference between the heat and temperature, right? You understood it? Yeah. Yes. Come to this part. Energy supplied to an object as heat exists as kinetic energy of the molecules, right? We discussed this. So the amount of heat stored in an object is equal to the sum of kinetic energy of all the molecules of that object, right? Sum of the kinetic energy අර ඔක්කොගෙම තියෙන kinetic energy වල sum එක තමයි අපි heat කියලා කියන්නේ. What we call temperature is a measure of the internal energy of an object. Now the temperature is a measure of heat, right? Or the internal energy is a measure of heat, amount of heat, gives a meaning, like gives an understanding about the measure of heat. That's all, right? Because the more the temperature, more the heat, right? That's there only we have to understand. The more the temperature, more the heat. That's all, right? If the temperature is more, the heat is also more, right? Right. In the flow of the heat from one object to another, the direction of the heat flow is determined by the temperature of the two objects and not by the amount of heat contained in the two objects. නේ heat එක flow වෙන්නේ කොහේ ඉඳන් කොහෙටද කියන එක decide කරන්නේ කවුද? temperature difference එක. නේ high temperature to low temperature තමයි heat එක flow වෙන්නේ. So that is decided by the temperature difference, right? Right. Right. So heat transfer කියන එක. හරිද? Heat transfer. So what happens when you are transferring the heat? How does it occur between two of the objects? Now let's think something like this. Right? Think something like this. Right? So think something like this. Let's say there are like two of the persons. Right? Another person. Right? So now two of the persons are here. Right? Listen. No other talks when you come to the class, huh? Because you have to transfer the heat. But no, nothing else. Right? So they are touching the hands to transfer the heat, right? So now what happens here? Now let's say that the heat or the temperature here is high and the temperature of this person is low. What happens now? The heat flows from the high temperature to low temperature. So the heat flows from this person to this person, right? Now while the heat is transferring, let's say this person is something 90 degrees or something, right? And this person is 30 degrees or something. Yes. So what happens while that heat is transferring? The 90 degrees of Celsius will be decreasing. The temperature will decrease. Now this temperature will decrease, right? This temperature will decrease. And what happens to this temperature? It will increase, right? Now his temperature, this person's temperature will increase. And at one point, right? At one point, this temperature is reducing, this temperature is increasing. At one point, the two of the temperatures will be equal, right? So until the two of the temperatures are being equal, what happens? The heat transfer occurs, right? Heat transfer occurs until the two of the temperatures are equal. And when the two of the temperatures are equal, we call it what? The thermal equilibrium, right? That we call it thermal equilibrium. So once they are in the thermal equilibrium, no heat transfer is there. Until then what happens? One is passing the heat, the other one is receiving the heat, right? That happens, right? So that actually happens in the nature as well, right? Mostly the one person is high tempered, so he is passing the heat, the other one is receiving the heat, right? Usually happens. In two of the couples, could be anyone, could be friends, could be family, could be the lovers, anyone. Someone is in high temperature, usually. The other one has to be,
Does that mean like
equally in the equilibrium thing. So they don't pass the heat.
there's nothing?
Not nothing. They don't pass the heat. Heat will take it as a mental stress. So there will be no stress. Like usually if the two of the temperatures are different, usually the high temper one will be passing the heat to the other one, right? That usually happens. And when they are passing their heat to the other one, the other one is also getting high temper. Their temperature is increasing, and they will come to equilibrium and they will stay there in the equilibrium until the connection is there, right? So when it comes to the equilibrium, what happens there is the flow of heat doesn't stop there. What happens there is the amount of heat passing and the amount of heat receiving will be in an equilibrium. That means if she passes 10 joules for this person receives a 10 and again gives back a 10 joules to her. So that means 10 is passed between two of the persons. ඒ කියන්නේ 10ක් මෙයාට දුන්නාම එයා 10 ගන්නවා. අරගෙන එයා 10ක් මෙයාට දෙනවා. That is equilibrium.
equilibrium එක කියනකොට එහෙම.
ඔව්. ඒක තමයි equilibrium. මේක කියන්නේ අර heat එක pass වෙන්නේ නැහැ කියන එක නෙමෙයි.
ඒ කියන්නේ heat එක ඔතන ඔක වෙලා නවතින equilibrium හැදෙද්දිනේ
ඔව්. ඔව්.
එතකොට දෙපැත්තම මාරුවන equilibrium කියනකම් ඒක කියන දේ පාස් කරගෙන ඉන්න එහෙමද?
ඒ කියන්නේ නෑ නවතින්නේ. ඒ කියන්නේ equilibrium එකට එනකන් heat එක කියන්නේ equilibrium එකට එන්න කලින් එයා වැඩි එක්කෙනා heat එක pass කරනවා. අනිත් එක්කෙනා receive කරනවා. equilibrium එකට ආවන් පස්සේ දෙන්නම pass කරගන්නවා දෙන්නම receive කරගන්නවා. කියන්නේ same amount වලින් දෙන්නම pass කරනවා දෙන්නම receive කරනවා. එතකොට ඒක තමයි equilibrium කියන්නේ අතරම. So there is no like මේ stop of a like exact මේ margin of a heat flow stopped. It's not stopping. It's actually under an equilibrium. That is why we call it equilibrium. The heat is passed like in the equal amounts between two of the persons, right? So that we call as the thermal equilibrium. So when and two of the objects with two of the different temperatures in a one system, the one with the high temperature passes the heat, the other receives the heat, and they comes to a equilibrium, and that in that equilibrium the temperature will be remaining constant. The temperature won't go low or go high when it comes to the equilibrium. It will be constant value. අපි එකට කියනවා thermal equilibrium temperature, right? Thermal equilibrium temperature කියලා කියනවා. If there are like 3 persons here, ඒ තුන් දෙනාටත් ඒකම වෙනවා. හොඳයි. If there were like 3 people here, it will be same for the 3 of the people. හරි. අපි තමු මෙතන තව එක්කෙනෙක් ඉන්නවා කියලා. right? එතකොට මෙයාටත් එහෙම තමයි. හරි. මෙයාටත් මොකද වෙන්නේ? heat එක එනවා. එතකොට මේ heat එක මේ තුන් දෙනාගෙම මොකද වෙන්නේ? තුන් දෙනාගෙම flow වෙනවා. සමානව නෙමෙයි. Now that is the thing. That is the next point we have to discuss. Would the heat transfer in equal amounts when they are in different temperatures? Let's say now this person is in the high temperature, this is somewhat low, and this is like the lowest, right? So depending on the temperatures, not only the temperatures, right? Not only the temperatures. අපි හිතමු මෙයා 100 joules පිට කරනවායි කියලා. And two of these are in the same temperature. හරි. දැන් එන temperature එකේ මෙයා දෙන්නගේ effect එකක් නැහැ. This person is also 30 degrees of Celsius. Now the temperatures are equal. Now she is passing 100 of joules. Now when she is passing 100 of joules, would it equally divide to 50 joules and received by the both of the people, or like would they receive different energies in a different fraction? සමානව දෙන්නේ different. Now that is the thing. That is the theory. That is the theory I'm trying to prove. Would it be equal or different? Different. You understand that? What is that different? Let's say now if this person absorbs 80 joules, this person only absorbs 20 to make it 100. What is the difference there? එයාගෙන් ඒතර අඩු වෙනවා heat එක. Now that is the theory I'm going to discuss next. Do you understand this part at least? Yes? I'm going to teach you. නෑ ඒ කියන්නේ මෙයාගෙන් 100 පිට වෙනවා. මේ දෙන්නට එහෙම නෑ. ඒ කියන්නේ මේ දෙන්න තුන් දෙනාම කනෙක්ට් වෙලා නම් ඉන්නේ මෙයාටත් යනවා මෙයාටත් යනවා. එකපාරට යන්නේ. ඔව්. මෙයාට 80 යනකොට මෙයාට 20 යන්නේ. ඇයි? That is the question I'm asking. Why does it happen that way? People online, why does it happen that way? මෙයා 100 මෙයාට දෙනකොට මෙයා 100 එළියට දෙනකොට මෙයා 80 receive කරද්දි මෙයාට receive වෙන්නේ 20. Why is that? Equal. 30. 30.
සමාන බෙදෙන්නේ කියලා.
ඔව්. Good answer. Come with a think. Why would it be differ? What is the difference? Think naturally. If it was you three in the family, why would it differ?
මට පොයින්ට් එකක් දෙනකොට හිතන්න ඕන.
Huh? Oh, ඉතින් හිතන්න. Why would it differ?
කැපැසිටි එක වෙනස.
Exactly. Now that is the point. Capacity එක වෙනස්. Because this person can receive more heat. This person can only receive a less amount of heat. That is the heat capacity. Temperature එකයි. Capacities දෙකක්. Yeah, capacity එක depend වෙන්නේ material එක. Now the water can receive much of a heat, right? So it doesn't increase its temperature all of a sudden. It slowly increases the temperature, right? Because the heat capacity of the water is very high, right? Very high. But what about the other volatile liquids? Like the cinnamon or petrol or diesel or something? It can't receive much of a heat. When the heat is receiving, it evaporates all of a sudden. So it doesn't have much of a capacity there. Let's say පොඩි ළමයි. නෑ තුන් දෙනෙක්. Three materials have three different capacities, right? So they are receiving different amounts of heats because they have different. Oh, එතකොට සමාන. ඔව්. එකම material එකකින් එකම mass එකකින් ඉදියන එතකොට සමානව ගන්න පුළුවන්. But different materials receive different heats because of their different heat capacity. So there's another thing there.
මෑස් එකක් තියෙනව නේද?
ඔව්. දැන් mass එක අපි අයින් කරන්නේ. mass fact එක නෙමෙයි අපි discuss කරන්නේ. නම් මේ දෙන්නගේම mass equal වුණත් receive වෙන heat එක වෙනස්. ඒ කියන්නේ එතකොට heat කියන එක depends on three things. What are the three things? First thing is the temperature. Second thing is the amount of molecule, which is the mass. Third one is capacity. So those are the three things that the heat depends on, right? Right. No. Different materials, same mass, different amount of capacities. අපි ගමු copper එකයි iron එකයි ගත්තොත් ඒ දෙන්නගේ heat capacities දෙකක් තියෙනවා. එකම mass එකේ වුණා. එකම heat එක දුන්නොත් එක්කෙනෙක් වැඩිපුර ගන්නවා අනිත් එක්කෙනාට ඉච්චර ගන්න බෑ. Right. That is heat capacity, right? So අපිට discuss කරන්න තියෙන්නේ now think something like this. The distance between peoples. No, not the distance. It's the heat capacity, right? You understand it now? Because all the people are connected there. So no distance is there. They are all together. So we'll take a real state one. Something not emotional. Now think of a metal cube heated up to 90 degrees of Celsius, right? And going to throw it on a beaker of water, of temperature 30 degrees of Celsius, right? Now once I drop it inside, what will happen? The metal will release the heat, or the metal will pass the heat, yes, and the water will absorb the heat or will receive the heat, right? So once when the metal is passing the heat, what will happen to the temperature of the metal? It will, what happens to the temperature of the object? Reduces, yes. So this will reduce, and when the water is receiving heat, what will happen to the temperature of the water? It will increase. So this will come to an equilibrium at a temperature which we call the temperature of equilibrium of heat, right? So this is what? Temperature of equilibrium of heat, right? Temperature of equilibrium of heat, right? So now if I ask to write a formula about it, what would I write? I would write something. ඒ කියන්නේ මේකේ සිද්ධ වෙච්ච එකට අපි formula එකක් ලියන්න කිව්වද? Right? So what will be the formula there about the heat? The amount of heat passed by the metal is equal to the amount of heat received by the what? Water, right? The amount of heat passed by the metal is equal to the amount of heat received by the water, right? That you understand? Right. So we are little by little coming to the questions, huh? So have some brain works there. Now come to this part. The heat capacity, we discussed it, right? So the first thing about the heat capacity, now the two of the capacities are there. One is just the heat capacity. The other one is specific heat capacity. Two of the things are there. One is just the heat capacity. Second one is the specific heat capacity. Now somewhat you understand the heat capacity, right? The amount of heat it can take, right? Some people can't take much of a heat. Some people can take very large amount of heat, right? So that is heat capacity. Now there is a difference between the heat capacity and the the specific heat capacity. We'll discuss it. Come to this point, right? Now we'll take the same example as we discussed. Let's say this is a person. Right. Now we are applying heat to this person, right? So you call this what? The real term is there in Sinhala medium. What do you call this? මේකට කියන Sinhala term එක now this is we are discussing the heat නේ. heat එකේ අපි මේ කතා කරන්නේ this is a object. We discussing it as a object wise. Sinhala we call it vastuwa. You call a vastu for the person sometimes. Let's take that vastu. In the science, the vastu actually means the object, right? The vastu actually means the object. In Sinhala, it says vastu. So this is an object, right? So you are going to apply heat to the object, right? So you are applying heat, right? So when the heat when you are applying the heat, what happens here is your temperature is increasing, right? When the heat is absorbing, your temperature is increasing, and at a certain point, when the certain amount of heat is absorbed, this person's temperature will rise up to 1 degrees of Celsius, right? This person's heat will increase up to 1 degrees of Celsius. So the heat capacity means the amount of heat that takes to increase the object's temperature by 1 degrees of Celsius, or 1 unit of temperature, because this could be Kelvin as well, right? So the heat capacity is what? Amount of heat that it takes to increase the temperature of the object by 1 degree of temperature. Understand it? The අපි ලියන just don't take the notes there, notes are there. I'm telling, right? So the amount of heat that it takes to increase the temperature of the